trace. Okay, so light sources, we have different light sources. We have following characteristics are to be considered when choosing the lamp of an application. So under the different light sources, we are going to measure on the discharge lamps, the construction of the discharge lamps, how they work. I think there is a time when we talked about them, but today we are going to learn more about them. Then we have the characteristics of different light sources. We have the luminous efficiency, that is the luminous flux, the lamp power, and the blast losses, the lamp life, the quality of the light that is emitted, the effect of ambient circumstances, the lumini, and the purchase and operation costs. Okay. So we go to the directly to our fluorescent lamps. We realize that fluorescent lamps are part of the discharge lamps. So when we talk about lamps, we have incandescent lamps, which are also called the general lighting service, that is the GLS. Light is produced by leading current through a tungsten wire. So the working temperature of the tungsten filaments with incandescent, I need you to mute your mics, lamps about 2700 Kelvin. Now, therefore, the main emission occurs in the infrared region. So the typical luminous efficiency of different types of incandescent lamps is in the range between 5 to 15 lumens per watt. So the advantages of the incandescent lamps, we said the incandescent lamps, these are a light. This is when light is emitted by heating up the filament when the tungsten wire is being heat up. So the advantages are it is inexpensive, easy to use, small, and does not need auxiliary equipment, easy to dim by changing the voltage, excellent color rendering properties, directly work at power supplies with fixed voltage, free of toxic components, and instant switching. Those are the advantages. What about the disadvantages? Okay, sorry for that. The disadvantages are here. Short lamp life, they have short lamp life. They have a low luminous efficiency. They have heat generation is high. Then the lamp life and other characteristics are strongly dependent on the supply of voltage. So the traditional incandescent lamps will be progressively replaced with more efficient light sources. For example, those ones that are supplied in somewhere in Europe. And then we have the tungsten halogen lamps. The tungsten halogen lamps are derived from the incandescent lamps. Inside the bulb, halogen gas limits the evaporation of the filament and redeposits the evaporated tungsten back to the filament through the so-called halogen cycle. Compared to the incandescent lamp, the operating temperature is higher, and consequently the color temperature is also higher, which means that the light is whiter. Color rendering index is close to 100. So as with incandescent lamps. Now, halogen lamps are available in a wide range. You remember we also talked about these halogen lamps. The halogen lamps advantages are they are small in size, directional light with some models, narrow beams, low voltage alternatives. These ones will always appear in your exams. The advantages and disadvantages of these kinds of lamps. And instant switching and full light output. They also have excellent color rendering properties. Disadvantages of tungsten halogen lamps are low luminous efficiency, surface temperature is high, lamp life and other characteristics are strongly dependent on the supply and voltage. So what are the tips to consider when choosing that halogen lamp is instant switch on and instant full light, excellent color rendering, and easy dimming, then frequent switching and others. So we now come to fluorescent lamps. Fluorescent lamps are lamps under the classification of the tungsten lamps, and we had discussed about them in estimation and tendering, but I want us to take another closer look at them. So fluorescent lamp is a low pressure gas discharge light source. It is a low pressure gas discharge light source in which light is produced predominantly by fluorescent powders activated by ultraviolet radiation generated by discharge in mercury. So the lamp, usually in the form of a long tubular bulb with an electrode at each end, contains mercury vapor at low pressure with a small amount of inert gases for starting. So the majority of the emission, that is 90%, takes place in the ultraviolet region of the wavelength of the main emission of peaks at 254 nm and 185, and hence the ultraviolet radiation is converted into light by the phosphor layer in the inside of the tube. There's normally a white layer that we see inside the tube of a fluorescent lamp. And then correlated color rendering indices, that is the CRI from 50 to 95 are available. So the luminous efficacy of the latest T5 fluorescent lamp is up to 100 lumens without ballast losses, dimming if possible down. Now you can see the diagram of the fluorescent light. We have the phosphorus coating, you can see the coating there, and then the ultraviolet radiation that is taking place there, and then we have the electrons and the electrodes that are moving to be able to light the fluorescent lamp. So fluorescent lamp displays a negative voltage current characteristics requiring a device. The fluorescent lamp displays a negative voltage current characteristics requiring a device to limit the lamp current. Otherwise, the ever-increasing current would destroy the lamp. Pure magnetic inductive ballast needs an additional starting element such as a glow switch. Electronic control gear incorporates all the equipment necessary for starting and operating the fluorescent lamp compared to the. And I would like you to go back to the notes and look at how they work and how they start, and even how we do the fault finding of that. And then advantages of fluorescent lamps are there. T and the CRI. The disadvantages are there that it has an ambient temperature effect that switch the switch on the light output. The need of auxiliary ballast and starter or electronic ballast is also making it complex. And then the light output depreciates with age. That is a disadvantage with the fluorescent lamp, and then contains mercury and the short burning cycles. So we have different types of fluorescent lamps. We have the CLFs. You can see the CLFs, how they look like. The CLF is a compact variant. They are called the compact fluorescent lamps. It's a compact variant of fluorescent lamp with overall length is shortened, and the tubular discharge tube is often folded into 2 or 6 figures. or a spiral. So for a direct replacement of the tungsten filament lamps, such as the compact lamps, are required with internal ballast and screw. You can now see they are the ones that are normally called there. You can get them. They're either spiral, and you know they are the ones that we commonly use these days. But in the real sense, these are fluorescent lamps. There is only that the shape has been changed. So some of the features is the difference. It is warm, white, cool, white. They have the instant ignition. Some of them diminished sensitive rapid cycles and the disable source, and some of them. So advantages of the compact fluorescent lamps are their good luminous efficacy, meaning they are very bright. They have a long life. They reduce cooling loads. They reduce cooling loads when replacing incandescent lamps. So they are the ones that have come in place to replace the incandescent lamps. Disadvantages are they are very expensive, and then their best are the E2F based are not dimmable. Their light output depreciates with age. That is also another problem. And then they have a short burning cycle, a shortened lamp life, and then they have a current wave form of the SFLs with the internal electronic ballast, which is distorted and contain mercury. So you can see that the different types of compact fluorescent lamps are there. And then the advantages of the pin-based lamp is that it is possible to replace the burnt lamp while keeping the ballast in place. That is the good part of it. High-intensity discharge lamps. They are also called the high-pressure discharge lamps. So we have talked about the gas discharge, and now we are on the high-intensity discharge lamp. So without any temperature limitation, e.g. melting point and tangent, it is possible to use gas discharge, that is plasma, to generate optical radiation. Unlike the thermal solid sources with continuous spectral emission, radiation from the gas discharge occurs predominantly in form of single spectral emission. Radiation from the gas discharge occurs. Okay, so these lines may be used directly or after the spectral conversion. So this is a way, or the components of the things that are normally in the high intensity discharge lamp, meaning they work under high pressure. They work under high pressure. So this high pressure discharge lamp cannot be dimmed. Others only in a power range of maybe 50 to 100%. So some of these are the mercury lamps. So in mercury lamp, light is produced with electric current passing through the mercury vapor. You can imagine electric current passes through the mercury vapor, and an arc discharge in mercury vapor at the pressure about 2 bars emits 5 strong spectral lines in the visible wavelength. And we already talked about the wavelength earlier on. So the red gap is filled up by a phosphor layer at the outer bulb. Somebody may ask a question like, now, Mwalimu, why do we learn about maybe the components of these lamps? Why is it important? Why don't I just learn about the construction of these lamps and maybe the working and finish with that? The reason is most of the time when you are in the job industry, you will sometimes find yourself placing yourself or being placed in a manufacturing farm that they manufacture these fittings or luminaries. So when you get yourself in that category where these luminaries are being manufactured, you need to understand even when they are being produced. You need to understand even the pressure that they're supposed to hold, the wavelength in which they're supposed to act, the components, the heat that they can absorb or they can withstand at a given specific time. So we have others called the metal halide lamps. To increase the luminous efficacy, the CRI of mercury high pressure lamps, it is useful to add mixtures of metal components to the filling of the discharge tube. So these additives emit their own line spectra in the arc discharge, leading to an enormous diversity of light color. So for sufficient vapor pressure, it is better to use metal halides compounds with iodine and bromine instead of elemental metals. So those are some of the substances or compounds that we can use. When the vapor enters the high temperature region of the discharge, molecules dissociate, the metal atoms are excited, and the radiation is emitted. Now look at these ones. These are called the metal halide lamps. They are the metal halide because the inside, you can see the tungstens are metallic, and the metal halide normal power, that is the 150. Most of these are being used in the floodlights. And a good example is the floodlights that use the metal halide lamps. So high pressure sodium lamps. In a high sodium lamp, light is produced by sodium vapor, the gas pressure being about 15 kPa. The golden yellowish emission spectrum applies to the wide parts of the visible area. So the CRI is low, that is 20, but the luminous efficiency of the lamps is 80 to 100 lumens per watt. So the lamp life is that. An improvement of the CRI is possible by pulse operation or elevated pressure, but this reduces the luminous efficiency. So color improved high pressure sodium lamps have the CRI. So you can see these are still the characteristics of these lamps. What are the advantages of the high pressure sodium lamps? The only difference with this and metallic is that these ones use sodium and the other one use metallic. So they are very good luminous efficiency. They have a very good luminous efficiency. They also have a long life of between 12,000 to 16,000 hours. They also have a high luminous flux from one unit one unit, that is from the street and area lighting. So look at them. That is how they look like. They have sodium in them that is used to be, that enables them to conduct. So we have electrodeless lamps. The burning time of the discharge lamps is normally limited to abrasion of the electrode. So it is possible to avoid this by feeding electrical power into the discharge inductivity or capacitivity. Now, although the principles of electrodeless, it means that it does not have electrodes. So the lamps have been understood for over the 100 years. Electrode lamps were not introduced into the commercial market until the past decades. So the main reason were the lack of reliable or low-cost electronics and avoidance of electromagnetic interferences. And now induction lamps, induction lamps. The induction electrodeless fluorescent lamps is fundamentally different from the traditional discharge lamps, which employ electrodes as electron source. So the operating frequency of induction lamp is usually in the range of hundreds, that is kilohertz, to tens, that is of megahertz. Special generator of ballast is needed to provide high frequency power. So you can see they use induction and when we talk about them using induction, so and remember we have said that they don't have electrodes. So when they don't have electrodes, they use the chemicals inside them. They use the compounds that have been put inside them to induce the flow of electricity or the flow of power inside them. Other ones that we have are the compact fluorescent lamps that are electrodeless, that do not have electrodes. So some models of the CFLs are electrodeless lamps. The advantages over common CFLs are at instant switching and good performance with switching cycles. Okay. Is that the comparison between the electromagnetic ballast and the electronic ballast? Because they have transformers in them that are able to step up or step down the power. Now, starters. What are starters? Starters are used in several types of fluorescent lamps. Now, when voltage is applied to the fluorescent lamp, the starter, which is a timed switch, allows current to flow through the filament at the end of the tube. So the current causes the starter's contacts to heat up and open, thus interrupting the flow of current. So the lamp is then switched on. Since the arc discharge has low resistance, in fact, a negative voltage current and characteristics. So the ballast survives as the current limiter. So what it means here is that the starters are the ones like they are like a switch in a fluorescent tube. They are like a switch in fluorescent lamps that they are able to start. So the moment the switch is pressed, it connects to the electrode, and then it is able to cause power to flow so that the lamp can start working. So the moment it is disconnected, it causes now the ignition or of elements, that is the mercury, the ignition, and so it can light. So electricity flows through it, and it makes it to light and produce light when it has the wavelength of the ultraviolet range wavelength that is able to light, or that can sustain the lighting of that bulb. So the moment the starter has been used to light the lamp, it can be removed. It can either stay there or it can be removed. So that's why in most cases you will see when people are doing maintenance or fault finding in fluorescent lamps, you realize that they will reach a point where when they use the starter, they can when the lamp is already on, they can still use the same starter to light another lamp. Now, there are another thing called the dimming. Dimmers are devices used to vary the luminous flux of incandescent lamps. So by adjusting the root mean square, that is the RMS voltage, and hence the mean power of the lamp, it is possible to vary the intensity of the light output. So some domestic dimmers are generally manual controlled, although remote control systems are available. Those are dimmers that are able to reduce the amount of light that is emitted by these luminaires. So we go to solid state lighting. Solid state lighting is commonly referred to the lighting emitting diodes, that is the LEDs. And we are majorly not going to discuss the LEDs today. So I'll go to another slide that will talk about the gas discharge lamp. So today, our main concern today was just to talk about the discharge lamps. And we have already talked about the discharge lamps being the gas discharge lamps are a family of artificially light sources that generate light by sending the electrical discharge through an ionized gas. We have already said the ionized gas, like even mercury. Typically, such lamps use the noble gases like argon, neon, krypton, and xenon, or a mixture of these gases. So most lamps are filled with additional materials like mercury, sodium, and or metal halides. In operation, the gas is ionized. The free electrons accelerated by the electrical field in the tube collide with gas and the metal atoms. So some electrons in the atom orbitals of the atoms are excited by these collisions. So gas discharge lamps offer long life. We had already talked about that. They offer long life, efficiency, a high efficiency, but are more complicated to manufacture, and they require electronics to provide the correct current flow through the gas. So there are three types of these gas discharge lamps. We had talked about the low pressure discharge lamps like the fluorescent. We have the high pressure discharge lamps, and we have the high intensity discharge lamps. So this is a simple diagram of how a simple discharge lamps look like. So we have an electrode there, and we have the arc. The arc tube is there, and then the sodium part is there, and the voltage and the ballast. So the low pressure lamps have working pressure much less than the atmospheric pressure. So they include fluorescent lamps, which we have discussed in details. The previous section we have already discussed, you saw that. And we have the low pressure sodium lamps, the most efficient gas discharge lamp types, that is producing up to 200 lumens per watt, but at the expense of very poor color rendering index. So the almost monochromatic yellow light is only acceptable for street lights and similar applications. So low pressure sodium lamps also have a long lifespan. I think we have even talked about, you can now see this is another example of that low pressure sodium lamp. Look at the way they are lighting. So we have high pressure discharge lamps. The high pressure lamps operate under slightly less or greater than atmospheric pressure. They include the metal halides, the high pressure sodium lamps, and the high pressure mercury vapor lamps. They are what we were discussing in the previous slide. So the above three lamps are also well known as high intensity discharge lamps. That is the HID. So the definition of high, the definition, the definition of a high intensity danger is discharge is related to the special type of electrode used in the lamps. So you can see that the high intensity discharge, now the HD, the HID lamps in general are very energy efficient and tends to have the longest service of life of any lighting type. We have the high intensity discharge lamp there. These things are always very expensive because of their composition and because of the materials that are used to manufacture them. They are normally very expensive. So the high pressure mercury vapor lamps are there. The high pressure mercury vapor lamps, often called the mercury vapor lamps, are the oldest types of the intensity discharge lamps. They are used primarily for street lighting. That is, the mercury vapor lamps provide about 50 lumens per watt. Mercury vapor lamps, majorly they use mercury. So this today I've not shown diagrams because last time we had talked about the diagram. I even gave you an assignment that has diagram and the construction and the operation. So I hope you are aware and you know about the construction and operation of these discharge lamps. And then the metal halide lamps are there. The lamps produce a bright white light with the best color reduction among the high intensity lighting types. So these are used to light large indoor areas such as a gymnasium and sports arena and outdoor areas. So those are some of the applications or areas where they are used. You can now see these are the good examples. We are the metal halide applications. Metal halide lamps have shorter lifetimes, that is between 5,000 to 200 hours, compared to both mercury vapor and high pressure sodium. So that is the end of that slide, and those are now the floor